Okay, so the question here says calculate the wavelength in nanometers of the light which would be required to break 1 mole of hydrogen to fluorine bonds using bond enthalpy data from page 10 of the data booklet. So I'll go to page 10, bond enthalpies here. Hydrogen to fluorine has a value of 570, so I'll keep that for a wee second. So it's asking me to calculate wavelength in nanometers, which is important, using an energy. So I know that energy equals LHC over wavelength, but this time I'm trying to calculate a wavelength, so I need to rearrange that to give us LHC over energy. So my LHC, my top line of that equation is just exactly the same. So Avogadro multiplied by Planck's constant multiplied by the speed of light. And this time I've got an energy on the bottom. So my energy, if I look, is 570 kilojoules per mole. So it's 570. But if I look at my unit for Planck's constant, it's still in joules per second. So I need to multiply this by 1,000 so that I make sure I've got consistent units, and I'm converting here kilojoules into joules to match with Planck's constant there. So I plug all that into the calculator. I get a value of 2.10 times 10 to the negative 7. My units here will be meters, because that's what speed of light is in, meters per second. Everything else just kind of cancels out. But I want to convert that into nanometers by dividing by 10 to the negative 9. That gives me a value of 210 nanometers as my final answer.